Hello everyone, welcome to our SLAM talk. My name is Enes. This study is about the neural basis of lexical representation. Processing models, especially simulation models, depend on typically ungrounded assumptions about representation. Our aim is to show that neural decoding techniques will help to empirically ground those assumptions. Very little neural work directly addresses the nature of word-level phonological representation. Let's think about how word forms are represented in the brain. When we hear a word like pig, if there is holistic representation, words are represented as units. If there is compositional representation, words are represented as subunits. Here we use biphones for reference, but it can be syllables or any endphones. Now let's look at the activation dynamics of word representation. With the holistic representation, we get a pattern of activation with overlapping words getting some activation. Since lexical representation inhibit one another, at the end, it is the winner takes all, so pig is activated. With the compositional representation, there will be a range of activations based on continuous variation, which results a far more complex environment. But at the end, the one with the strongest activation wins. Although both accounts get there and show some overlapping activation, the compositional account is more complex. As for the non-words and representation, there are all kinds of results showing that lexical similarity influences processing of non-words. With this in mind, when we hear a phonotactically legal non-word like pug, for the holistic account, all of the equally weakly candidates simply cancel one another out, and there is no activation. Therefore, the ability to report pug ultimately relies on factors outside of the lexicon. For the compositional account, after the lateral inhibition dynamics plays out, we end up with a single representation. Critically, there is potentially full representation of non-words in the lexicon according to the compositional account. To sum up, compositional representations support non-words, but holistic doesn't. Therefore, the question that we are interested in is, are neural representations of word form compositional or holistic? And here are some details about our methodology. So we collected simultaneous MEG-EEG data with structural MRI from 12 native English speakers while they complete an auditory lexical decision task. We are using source space reconstructions of MRI-constrained MEG-EEG data. We do neural decoding using support vector machines. So SVMs were trained to discriminate neighborhoods and tested on hub words to measure if transfer learning occurred. For example, SVMs were trained on words and non-word neighbors of pig and toad and tested on pig versus toad to examine the effect of lexicality. Make sure this is a hard task because we are using transfer learning and the stimuli is coming from 8 different talkers. We hypothesize that classifiers trained to distinguish between members of lexical neighbors of 2 words should also be able to distinguish those words without additional training. If lexical representation is holistic, then non-words wouldn't produce similar transfer learning. If lexical representation is compositional, then training on non-word neighbors of the same words should also show similar transfer learning because those items will activate the same components as lexical neighbors do. We are specifically looking at 5 ROIs, and in the literature, word form representation is associated with the posterior middle temporal gyrus, temporal pole, and supramarginal gyrus. In addition to these ROIs, there are 2 control ROIs that we had looked, and the central one is the central gyrus, and the other one is the frontal pole. Now let's look at the results. So for words, SVMs successfully discriminated hub words after training on word neighborhoods with PMTG and temporal pole, but not with the control regions and SMG activation series. As for the non-words, training on neighborhoods resulted in poorer classification, and which means none of the ROIs showed successful discrimination. Based on these results, we can conclude that training on neighborhoods help to detect hub words due to the overlapping activation patterns. However, the fact that non-words do not decode suggests that there is no direct representation of non-words. These results are consistent with the predictions of the holistic word form representation hypothesis and demonstrate the potential utility of neural decoding techniques. As a concluding remark, we want to stress that our results should inform the interpretation of non-word processing and modeling of activation dynamics. Thank you.